A fly is minding its own business, buzzing around a road, when suddenly, whack! A car at 70 miles an hour hits it and squashes it all over the windscreen. For the people inside the car, it's just pretty disgusting. They turn on the windscreen wipers and that just kind of spreads the mess around. It doesn't really help. But here's a question for you. Why was the car completely unaffected when the fly was squashed to oblivion? This might sound like a stupid question, but seriously, why? It might surprise you to learn that according to Newton's third law, the force on the car was exactly the same as the force on the fly. Welcome to Flip Physics. Today we're going to talk about squash flies and also Newton's third law. I guess I should have started with the Newton's third law part. Newton's third law is very often said like this: for every action there is an equal but opposite reaction. But that's not very useful. Our definition is going to go like this: if body A exerts a force on body B, then body B exerts an equal but opposite force on body A. So if you push on a wall with a force of 50 newtons, then the wall is pushing back on you with a force of 50 newtons. And incredibly, the car and the fly both felt the same force. But we'll go back to that. Right now, I'd like you to stand on your chair. No, seriously, get up right now and stand on your chair. I want you to have a spot that you're aiming for on the floor. I want you to have a spot that you can jump onto. Okay, are we good? I'm going to count to 3, and on 3, I want you to jump to the ground. Okay, 1, 2, 3. Now when you did that, did you feel it? Did you feel the earth come up to meet you? No? Well, maybe not. The earth actually didn't move that much. You did most of the moving, but the earth did move. The earth applied a force to you, the force of gravity pulling you to the ground, and by Newton's third law you must have also applied a force to the earth, pulling it up. You applied an equal but opposite force to the earth. So why did you do most of the moving? The reason you move so much more is because the Earth's mass is huge. You are very, very tiny compared to the size of the Earth. So even though you applied the same number of newtons to each other, that caused you to accelerate a lot more than it caused the Earth to accelerate. So the same force just didn't have the same impact on the Earth. Think about it this way: in terms of Newton's second law, F equals ma, you were pretty small. And so a particular force had a big acceleration on you. But there's a better example to explain this. Let's go back to the fly in the car. We can analyse that motion using Newton's second law, F equals ma. So we know that according to Newton's third law, the overall force that the fly in the car felt were equal to each other. And that force is going to be equal to the mass multiplied by the acceleration. The car has a big mass. And if a fly hits your car, does it make the car slow down at all? I mean, maybe it startles the driver and he presses on the brake. But assuming that doesn't happen, does the fly make the car slow down? Well, it kind of does, but hardly at all. You can barely notice it. So the car has a very tiny acceleration. The fly, on the other hand, is tiny. It has a minuscule mass. But the fly has a huge acceleration. The fly was just minding its own business, and then suddenly, whack! It's going at 70 miles an hour that way. By Newton's third law, these two forces are equal and opposite, so we can put an equal sign between them. And that's how it's possible these two forces are the same. Because one has a big mass and a tiny acceleration, and the other has a tiny mass and a big acceleration. The reason the car is in a wreck is because it has this huge mass, and that huge mass makes it much harder for the car to accelerate. The thing that you feel, the pressure on your body when you're driving around a corner in a car or slowing down and speeding up, it's the acceleration that you feel. It's the acceleration that puts stresses on your body. So the fly, undergoing this huge acceleration, went squish. Which reminds me, I should probably go clean my car. Side note, we have now covered all 3 of Newton's laws of motion. That makes this a great time to recap. To see a TED Ed video talking about Newton's 3 laws, click this link. Thanks for watching Flip Physics. Please comment below with your questions, thoughts and suggestions. If you like the video, feel free to press the like button, and you can also subscribe. Until next time, keep questioning. The angels have the phone box. Don't blink. Don't even blink.